All right, we can start. So this is Sanity with Terraform. My name's Spencer Herzberg. I'll tell a little bit about myself on the next slide here. I'm an independent contractor here in Des Moines, so I think most people come up here and say that we're hiring, but my accountant has told me that I can't do that, but I could be hired, so there you go. I'm a software dude who likes to run my own code. I think the first keynote was all about as a developer, you should know how to run your code, how it behaves. I like doing that, so that resonated well with me. I have a programming background, a computer science degree, so I kind of came from the programming land, kind of moved into the ops type of world. I've run Terraform for a few years in various states of real production usage. Currently, I'm doing Terraform not as like production, running services, but as infrastructure-y things like people depend on the services that the Terraform is spinning up, like our developers depend on that, not that we're running production code in there. And then I also I help manage two small startups, and their infrastructure is all Terraform. And I feel like that's a huge thing with Terraform, and I'll talk about it a little bit later. These startups, I only talk to them maybe every 6 months, but having Terraform helps me come back in 6 months and be like, well, what did I set up? It's all right here in code. So if you are wanting to do startups or something like that, maybe an option, because you might not do it every day because you have a regular, real job. I run the DevOps DSM group. Some people have asked about it a little bit. How do you get connected with that? We're a group that meets once a month here in Des Moines. We talk about different things like tools, processes, kind of like this conference, but much lower key. If you'd like to get involved, we have a meetup, a meetup.com space. Check that out. We're trying to use that as the moving forward way to notify people on new meetings, have conversations. Some people have already talked to me about upcoming talks that they'd like to give. So if you want to get involved, check it out or talk to me afterwards. I'm also a hobbyist woodworker. I don't know why I throw this up here, but I'm super passionate about it. So if you need a table dresser or even just a cutting board, let me know. So a little overview. We're going to talk about what is Terraform. I saw some hands about people running Terraform, so some people know what it is, but if you don't know, we're going to talk about that. Why should you even look at Terraform? There's lots of options out there, so why Terraform? We'll talk a little bit about workflow and syntax. I'm not so worried about that in this talk because every company is different. How you work with Terraform might be different than others. And then the syntax, who cares? You can go look it up. But there is some interesting things about Terraform syntax that I'll talk about. And then we'll go through a whole bunch of features of Terraform. I don't know why I came up with an acronym for FOT, but I think it'll just help me remember later to keep saying that. And then I have a very brief Amazon plus Terraform rant that I'll talk about. So what this talk is and isn't. First of all, this is not a talk about how you should use Terraform. I think a lot of the talks at DevOps days in general are like, hey, we did this thing, you should do it too, because now we all have yachts and we saved all this money, right? This is not that. This is this is just about Terraform, really. It's a tool talk. I know the keynote said this shouldn't be about tools, but that's okay. And this is not about how you should manage your own resources. Again, every company is different. If you're a startup, you're going to worry about maybe money a little bit more. So how you manage your resources is different than a big enterprise that is throwing cash at their problems. So I'm not going to talk about how you should do it. I'll talk about it later. I do have opinions on maybe how you should, but this talk is not that. And if you want to talk to me afterwards, do that. This is about how you can use Terraform to do the things above, not necessarily how you should, but how you could. And then if this makes you sad, ask me after. I do have lots of opinions. So what is Terraform exactly, and what does it do? This is from HashiCorp Marketing. It codifies APIs into declarative configuration files that can be shared amongst team members, treated as code, edited, reviewed, versioned. Right? The big differentiation point about this is, versus how you may have thought about Terraform, is it codifies APIs in general. It's not managing Amazon. It's not managing servers, right? It's just codifying APIs. It's a generic tool, okay? So maybe maybe a little bit easier to understand. It's just a generic tool to manage the CRUD of your resources, and obviously sanely, so I said that. So you have these resources that exist out in the world, very abstract thing, that you just want to manage the creation, the reading of them, the updating, and the deleting of them, right? That's all Terraform does. So why should you look at Terraform? Terraform is open source, and it's built by a company called HashiCorp. If you're not familiar with HashiCorp, they're a really awesome cloud native company that builds all these tools for developers to use to build their applications. Super awesome company. They're kind of like the hot thing right now, but they do have a lot of really good corporate backing stuff. So if you're not into the hot, shiny new thing, they are backed by and are used by very large companies. So it's not as scary, I think, for bigger companies to get into. Terraform's super easy to get started. The installation is super easy. Not that it matters, but the Terraform is written in Go, and Go allows you to produce just binaries for systems. So if you want to start today with Terraform, you just go to their website, download Terraform, and just run it as a binary. You don't have to install anything else. There's no other dependencies. Terraform has a very fast-growing community. They have lots of different open source providers and plugins and tools that you can use with Terraform. There's even companies that have cloud APIs that are writing their own Terraform tools because they realize that Terraform is kind of a cool thing. HashiCorp also provides a bunch of best practices. If you go to their website, the last point here is docs are good. If you go to any one of the HashiCorp tools, their documentation is usually really, really good, and they always have awesome examples. And then the third point that they do too, occasionally on their tools, is they provide use cases versus other tools. So for Terraform, they talk about one other tool that's kind of a competing thing, but not really, is CloudFormation. They talk about how they're different and maybe why you would want to use one or the other. So that's kind of cool. And then if you're into it, Terraform Enterprise is a thing. They provide services on top of Terraform. So if you like Terraform workflow, but you don't want to build out the infrastructure to manage Terraform, you could just pay them to do it. They have some really cool tools. And that's kind of a growing thing that they're changing all the time. Sorry, let me check my clock. All right, we're good. All right, so a quick high-level abstract example. This is not how like I said, this is not how you should do it. This is just a possibility to get you to think outside of the box in terms of Terraform and your infrastructure management. So let's say your company uses GitHub as your code repository, okay? Each member of a team on your GitHub organization requires some database access to this one server that's like this shared thing, right? You need a username and a password. And then each member also needs a developer's workstation. Like maybe you give them a Chromebook, but they are going to use this other server to do their main development. Hypothetical, right? I'm not saying you should do that, but you could. So how could Terraform do this for you? So this is a problem with working on a 4K or almost 4K laptop and presenting on here is my image is a little bit squished. This one might be the worst one, so the other images will be better, I promise. So just ignore, I said I wasn't going to do that. Ignore the top part about the provider config and the data stuff, but just look at the resource definition. So we have this resource block about halfway down that says MySQL database, and then here's the database. So there's the configuration for this shared database that you have, right? The next block, the resource MySQL user, is the definition for creating a user and a password for that database for a user. I'm going to walk through more detail on how some of this works, but you can see in the user line there, you can see that actually is referencing a part of the other Terraform config up at the top. So basically that's saying for every GitHub member in your org on this team, create this resource block for the user. And then the last bit there is creating the actual developer's workstation. So same idea, for every user, you're just going to create them a server. And this server happens to be on DigitalOcean. DigitalOcean is just super easy to set up. So this demo code actually works. I'll have the link at the end. But you could go spin this up and try it out if you wanted to. And then the last little bit there is some output. So I'll talk a little bit about how output works. And obviously, I'll dive into more about how each of those blocks work. But this is just a quick example. So there's my Terraform config on the left side. And then on the right side, I have this thing in Terraform called the plan phase. So with Terraform, you have a configuration file that you're saying what you want to have happen. And then you have this phase where you can say, well, what is going to happen, right? So on the right side, I have all the things that are going to be created. And I'll go into more detail about how this works, too, in future slides. But it's just saying I'm going to create a DigitalOcean droplet. and then I'm going to create the dev database, and then at the very bottom, I'm going to create a database user for my user, which is Herzberg. Cool? So just a quick example, just to make you think kind of outside the box on how you could use Terraform. So let's talk a little bit about the workflow of Terraform that I have kind of been alluding to. So basically it's this. You get into a folder and you add some Terraform files or some JSON files. And I'll talk about that, how that works later. And you just put them in this folder, and then you do this thing called a init. And so a init is, I guess I kind of think of it like a git init. You're setting up Terraform to be able to run, right? It's setting up some metadata information. I'm just going to skip past that. It's not important. But there's this plan and refresh phase. So with Terraform, you can see what's going to happen when you are going to apply your configuration. And then there's also this refresh phase to see like the drift, a potential drift between what exists in your resources and what exists in your configuration files. Again, high-level stuff. I'm going to cover this in a little more detail in a minute. And then you have an apply and a destroy type of workflow. So you're going to either create resources or delete them and potentially update them as well. And then these last 3 bits on the bottom are just kind of things you could do. One thing is to validate. So like you create all these Terraform files. You have hundreds of Terraform files. You need a way to make sure that that is like syntactically correct. You're going to validate. That's one thing. Another thing is state management. I'll talk about that a little bit later, but Terraform has this concept of state. And then there's output. So let's say you have a workflow where you're going to create a bunch of resources, but some other process down the line, like a security scan or whatever, needs to use those resources. Output is a way to transfer the metadata about the things you're creating to other processes. And then on the right here, I just threw these 2 pictures in because I feel like I do have opinions on how this should work, but I'm not going to talk about them now. But you have some of these things that you want developers to do, right? The top thing is a developer. So as a developer, I need to be able to do some of these things. I need to be able to apply changes. I need to create resources. I need to delete resources. But then there's a whole bunch of these things too where maybe you don't want developers to do, like maybe destroy. And maybe the bottom box is Travis CI. If you're not familiar with the logo, it's just a continuous integration platform. Maybe you have Travis CI do the things that normal developers shouldn't be able to do, like in production. Again, not gonna give opinions on how that should work, just saying that some of these things you don't want to run on your laptop and vice versa. All right, so let's talk about Terraform syntax briefly. Terraform has the concept of variables. So variables, the very top block there is a variable definition. So variables can have types. You can do strings, lists, integers. You can do maps. And so that's how you would define a variable. So I have this instant count variable. With variables, then, you can also do interpolation. So if you look down, I'm not pointing over there because the camera gets funny on the record when we switch over here, but you can see my mouse here. So if I go down here, there's some variable interpolation, this bottom line here. Inside the string, I have some things going on. So there's a function that I'm calling called join. You can do variable replacement. There's another one here that's just taking the instance count and setting it to the count attribute. So you can do some interpolation. I already mentioned functions. There's a ton of these. I also have another function call here called UUID. There's a whole bunch of helpful functions that you can use inside of Terraform config files. And then you can also provide overrides. So I'm not really going to talk about overrides too much, but in this example, I'm setting a default of 3 for instance count. But let's say your production server needs, your production environment needs 9 of these things. You could provide in the production apply stage, you could say, actually, I want this to be 9 instead of 3. So that's totally possible. And then outputs, I mentioned that earlier. Outputs are a way to just get data out of your Terraform runs into other processes. Easy peasy. And then you have resources. So here's the resource block right here. Resources are the things that you are creating, updating, reading, and deleting. Right? This could be anything. This example happens to be an AWS instance, but I'm going to talk about some other ones that you could use in other slides. They're just the things that you're manipulating. And then you have these data blocks. Data blocks are really cool. I have another slide about this, but data blocks allow you to basically read in state or information from other resources that are already defined. So for example, this one happens to be really cool and is somewhat new. When I first started Terraform, you couldn't do this. this data block actually looks up an AMI. So if you're familiar with Amazon, you can go out to the Amazon search, the AMI search, type in what you want, fire up an instance. Well, this does that for you. This does that for you. You provide these different filters to tell it which AMIs you want to even look for, and then you can use that output down here. So in this block now I'm doing some interpolation to say, okay, find me the latest Ubuntu 14.04 AMI, and I'm going to use it when I launch this instance. Super cool stuff. But again, there's tons of other data types that you can use. And then modules. So if you want to do reusable bits of Terraform, modules potentially are a way you could do that. And I'm going to have another example, a more concrete example about how that works. So the FOT thing, the features of Terraform. One of the differentiating features of Terraform is that it is declarative. And so I like to describe this as there's 3 parts to the Terraform runtime. The first part is your Terraform configuration. You have the TF files or JSON files, the ones that we've been looking at already. So that defines what you want your state to be. That's your end game, right? That's what you want it to look like. Over on the right-hand side, we have our resources. So these are the things that get generated. So we have database users, AWS instances, DigitalOcean droplets, SSH keys, stuff like that, things you're creating. Well, the thing in the middle that Terraform keeps track of for you is called the state. And this is like the output of what Terraform created, updated, deleted, and read from your resources. That's like what Terraform thinks it should have done, right? So you always have this like back and forth type thing of checking the state versus checking your resources. So let's take a look at an example. Let's pretend like I have this set of resources up at the top. These are super abstract, but these are DigitalOcean tags. They're just labels you can apply in the DigitalOcean cloud. So the first one I have is the foobar tag, right? And the second one is the baz tag. So I have 2 tags that I've defined. So when I do my Terraform plan, Terraform's telling me, hey, I need to create these 2 things for you. I'm going to create the baz one, and I'm going to create the foobar one. Easy, right? So I do the apply, and I go to the DigitalOcean console. I can look at my tags now that I've created. Works great. Let's say I have a pull request and a ticket come in that says, hey, we actually don't need the baz one anymore, so you can just delete it from your Terraform config. So assume the version 2 of my Terraform config is the second block here, which is I only have my foobar one. Because Terraform keeps track of the state of what it did before on applies, it can determine that, hey, I actually need to remove the baz tag that you created earlier. Super, super powerful. I don't have to actually code the delete, right? In some configuration management tools that I won't name, you have to actually say, I want to do something to actually have it done, right? Declarative just says, I just have an end state. Get me there however you want. So to get to the end state here, I actually need to delete the baz tag. Easy peasy. Cool. So another feature of Terraform, it's cross-provider out of the box. If you remembered nothing else from this talk, remember this slide. Kind of hard to read, but there's a ton of different providers. All these providers give you extra resources and extra data elements that you can use in your Terraform config. So for example, we use, at the contract I'm on right now, we use PagerDuty as our alerting and monitoring and midnight wake-up phone call type thing. PagerDuty has a Terraform provider. So I can configure PagerDuty from Terraform. I don't have to go through their UI. I don't have to call their APIs. I don't even know if they have a CLI. But if they had a CLI, I wouldn't have to use it. I could use Terraform to do that. All of the large cloud providers have providers have their own Terraform provider. DigitalOcean actually writes their own Terraform provider, and it's part of Terraform like proper. So you have a cloud provider that has embraced Terraform so much that they write their own provider for Terraform, which is pretty cool. So if you have a bug with it, you just go straight to the source. Pretty awesome. The right-hand box here is just a Google search on Terraform providers that are out there. A lot of these repository results are probably forks, but just ignore that. Just assume that there are a lot more that are not on this list that are open source. You can just Google for them. I'm just going to gloss over this because lots of people have talked about this already at this conference and others. Terraform provides you infrastructure as code. You get versioning, you get auditing out of it. Like I said, lots of other talks talk about this, so I'm not going to. I assume you think this is beneficial, so Terraform actually provides you infrastructure as code. Has anyone worked in a language that has style guides for the language, but also the language produces some way to enforce those style guides, and there's no other way you can write the code, the format of the code? Has anyone worked in a language like that? Python? Okay. That could be one. So Terraform has this, and they call the tool Terraform Thumped. If you want to look up I argue with people on how you pronounce that, but the Rob Pike, the guy that wrote Go initially, he said it in a talk. It is Terraform Thumped and Go Thumped. I don't know why I said that, but I argue with people about that all the time. So Terraform has the same thing. You cannot, if you run Terraform Thumped, you cannot get between two developers two different syntaxes for the same file. It's not possible. The file's reformatted. So one opinion that I will say is just you should do that. And if you're in a language that provides you that ability, you should run their tool, and so you don't have weird diffs between one developer to the next on how the code's formatted. It's a dumb thing to argue about. Don't argue about it. Just do what Terraform says to do. Right? HCL. HCL is pretty sweet. HCL is a tool that was built by HashiCorp as a configuration language. Right? They got sick of writing YAML and JSON, so they came up with this new thing that actually can compile to JSON, but that's beside the point. So HCL is a way to have types and have structure with configuration things, and you can have comments, which is nice. But because of HCL and the way they wrote it, you can actually convert from HCL to JSON. And you can go from JSON to HCL. So one use case of this is, let's say you found this way you want to build your infrastructure that cannot be defined easily in Terraform configuration. Like maybe in production you have this one thing that doesn't ever need to run, right? That might be hard to do in Terraform, depending on your use case. So one way to do that is to just generate a JSON file of what your production configuration should be, and then you have some test or something that says, well, in production, I don't need this resource, or I don't need this set of resources to be created. So that's one possibility. And another possibility is, there was another talk yesterday from the great Luke about how they use JSONet to generate JSON files based on upstream processes. So you have some upstream process that dictates what your infrastructure should look like. You could just generate a JSON file of your Terraform config instead of writing the Terraform by hand. You can also mix and match. So if you have some bits that are going to be generated from some upstream process that you can't do easily in HCL, you could just generate that bit in JSON. Pretty cool. If you want to use HCL in your own language, there's lots of different languages that support reading and writing and parsing HCL. Terraform provides convenient abstractions. I have an asterisk there because you can go overboard with this, like all abstractions. But here is the module, the module syntax. So let's say my company has two ways to run services. One is like a totally PCI compliant service. It always gets SSL. It always gets these sets of properties. But I also have this set of service that I've called the cheap yucky service that you just have one instance of. You don't care about SSL. But these are the two standards, right? Nobody else in your company should be able to run a service in your infrastructure that are not one of these two things. You could wrap that set of infrastructure in a module, and then they can reuse that. So if they come up with new service XYZ, and it needs to be a PCI service, you could have all of that configuration abstracted and reused over and over again. Cool. With Terraform, you can manage existing state. This comes into play if you use the Kaizen approach of implementing infrastructure. Right? You're doing incremental changes to make your infrastructure better. Let's say you have a cloud provider that you've gone in. You've just clicked buttons and said, hey, I need 4 of these instances. But now you're like, hey, that was kind of dumb. I shouldn't have done that by hand. You can import that information with Terraform into your configuration and use that elsewhere. Another way you can do that here is with importing existing state. So let's say you have a team that has that manages some set of your infrastructure. Like they manage the users, they manage access to the database, and they're the only ones that can manage that. Well, this data block at the top here says, I want to use that in my configuration. I'm an app developer, so I need to use I need to use the information for what's the main VPC. Let's say the infrastructure people also manage an IDS for intrusion detection. I just need the IP addresses of those so I can talk to it. I don't need to manage anything about it. So with this existing state, I can just import those bits into my infrastructure. There's no hard coding of values and stuff. You can reuse outputs at will. Another thing you can do with Terraform is state manipulation. State manipulation is also used for refactoring. So let's say you have a module that you are moving some of the resources into another module. If you were just to do that in your code and do apply, you would probably get a bunch of resources that get deleted from the one module and then re-added in the other module, right? Because they're different resources in Terraform sense. Well, if you didn't want to do that, let's say you have a database that you want to move from one to the other, you don't want your database to be deleted and then recreated. You'd rather just have Terraform know that, well, this database resource is actually is moving over here. So there's state manipulations that you can do. Super helpful for refactoring and changing how your Terraform's reconfigured. Terraform has these state backends. These state backends, normally when I was doing these demos, like if I were to look at the state file, this database file of Terraform state is local. It's just a JSON file. However, some people don't like that because then how do you transport that between different developers or different servers? So Terraform came up with this thing called remote state. So you can store your state externally. You can go look those up. There's a handful of them. You can also store them with encryption. So for example, if you're using the S3 state backend, you could have your state encrypted always at rest. So if you have secrets in there, you're mitigating the fact that someone could just look at those easily if they got access. There's also state locking. So if you have two developers, again, not that you should do this, but if you have two developers running Terraform applies to the same set of resources, they're going to be in contention with each other, right? So state locking, if you're using a correct backend that supports state locking, you can prevent users from overwriting people's changes. Pretty helpful. I already mentioned secrets and state. This has kind of been a contention with Terraform for a long time. They used to just write the database passwords right to the state file. So if you had that locally, you'd get a database password, plain text on your computer. With remote backends, you're kind of mitigating that because the state now is never written to your machine. It's always in memory, or it's always in the server's memory if you're running it from a CI box. And then I don't know much about workspaces other than from what I've read, what I like to do with Terraform, you can get around how workspaces work, but workspaces allows you to switch between different sets of states of files. And check that out if you're interested. Maybe some of you are using it.
We use it for environment management. That's all certified.
Perfect. Cool. Oh man. So you can manage existing resources. I kind of mentioned this earlier, but you can import things. So like I said, you've manually created some resources with the GUI or some other tool, but you want to now put it in Terraform. You can do what's called an import. Super handy, again, for refactoring and moving off of whatever platform you were using to manage your infrastructure. Provisioners, I'm going to breeze through this. So let's say you boot up a server and you need some bootstrapping step. You need it to check into Chef or check into Puppet or whatever you're doing for that kind of management. Provisioners allow you to run SSH commands or run a local script. So if you have some local script that has to ping an IDS to tell it about a new server, you could do that with a provisioner. I mentioned the custom plugins earlier. So plugins are providers. So if you have some custom API that you need to interact with that there isn't a provider for, you could just write one. They're super easy to do. They have great APIs. They also have a testing framework built in. So if you want to test your provider out, Terraform and HashiCorp people have made that super easy. So brief AWS Terraform rant. So I hear this a lot. I'm in AWS, so I don't need Terraform. I have CloudFormation. Lots of AWS only people say this. However, you probably, based on what we've talked about already, you probably are realizing that you don't have just AWS resources. Unless you're like super modern, you only have lambdas or something in your new stack. You probably have other resources, right? You're using PagerDuty, you're using Datadog, you're using all these other things. You could manage all of those things in one tool. You don't have to then, oh, that's time. You don't have to use separate tools to do it. Totally possible with Terraform. Terraform provides, but if you're still like, hey, I'm still in Amazon, I'm going to use CloudFormation, whatever, that's cool. But Terraform does provide you awesome workflow features. So you can manage stacks and environments. You can manage promotion from environment to environment. So something I've seen is that where this could help you if you're CloudFormation only is managing stack parameters. So you have these parameters that maybe you're storing, you're not even storing, you've just edited them in the Amazon UI. Terraform can actually manage CloudFormation stacks. So if you want to manage all the parameters, you want to manage updating a stack, you can do that from Terraform. It's a good way to get started with Terraform if you're not already using it. And then there's also things, this is kind of a side point, there's also things that Terraform can't and won't ever do that CloudFormation does. One example of this is auto-scaling group update policies. Terraform doesn't do that. So if you have an auto-scaling group that you want to update the AMI for, it doesn't handle rolling out a new AMI, but you can do that with CloudFormation. So maybe you do need part of CloudFormation to do some of the things Terraform can't do. So if somebody ever says, hey, we should use CloudFormation, just remember old advice here. What about the Terraforms, though? If you're familiar with Key and Peele, that should be funny. Any questions? Yeah?
Is it possible to use Terraform as a custom resource within CloudFormation?
Okay, so yeah, so I looked into this a while ago. You can actually write custom resources for CloudFormation, and they end up just being Lambda calls. So you write this thing that calls a Lambda that can do other things to interact, kind of like how Terraform providers work. You could write your own custom ones for CloudFormation. I don't know if one exists for Terraform, but you could write one. Don't do that.
So if you've got resource contention and you've got state lock, is it lock both? Or does it take the first one in, or is it based on your determination?
So if you're just talking about like two developers trying to talk to the same state, yeah, it's the first one that grabs the lock gets to do an entire Terraform run. So the entire run of your plan phase. If you're the first one in, you get to do the entire run when you're done, and then it releases the lock. So it's resources and it's the state at the same time. Yes. Sure, good question. I'll repeat it. So how do you manage the pull request process so you don't have two developers developing against the same set of resources causing issues with each other, basically?
Specifically in the dev environment, where do you test that your stuff
Sure.
is actually getting built in your infrastructure without
Gotcha.
messing with people's infrastructure in the dev environment?
All right, so here comes an opinion. I don't think you should do that. I think because Terraform, because I can run it on my machine, I should be able to spin up a dev environment from my machine. So when I'm testing changes to what, like let's say your dev environment is just a call to a module, so it's your super awesome service module, right? If I'm testing changes to that, I should be able to spin up that entire module by myself, not affect any other users. And when you're talking about merging that in, you submit a pull request to the module. Well, then that module can be planned against your dev environment. So you have your pull request builder, if you're in GitHub terms, would do a plan against the dev environment. And so if you have multiple of those, yeah, you'll have to manage which one gets merged first, but they'll be both independent plans potentially, right? Does that help?
Yeah, maybe I'll follow up with you after this about how you do that on your own.
Okay. Hey, good point. Any other questions? Ideas? Anyone do anything that they'd like to share with Terraform? I'm kind of curious. Otherwise, find me afterwards.
Yeah, I have a question.
Yeah.
So, confirmation, or rather, when you're setting up like a security group in the GUI, you accidentally delete the resource, and that confirmation manages that particular resource by an ID that is automatically generated. Essentially, can you like, if something gets deleted in the GUI, such as a security, can you just create a new one and then take that ID and swap it into your state file?
Sure. Yeah, it's a good question. So what happens if, just repeat, so you've applied some state, somebody goes into the management UI, mucks up the state, how could you resurrect that, or how does it, how can you fix that, right? Is that the question? Okay, so two points to that. One thing I didn't mention was, with this state file, let's say you do that, you go delete the security group, and I do a Terraform plan. Terraform's going to say, oh, that's gone. I need to recreate it for you. That will happen. So that's one way. The other way is what you suggested was you could just go create that back manually, and then you get the ID of whatever the resource is, and you can do a Terraform import to put it back and say, well, that resource you think you need to add, it's actually this one. Don't go re-add it because I've fixed it already. That's a good question. So we have that happen sometimes, not all the time. Somebody goes and monkeys with egress and ingress stuff on a security group. Terraform will tell me the drift of that and then fix it for me, which is super handy. Good question. Anything else? Thank you.